Welcome to Algebra 2, Unit 1, Lesson 3, Domain and Range with Restrictions. Interestingly enough, the domain of the buffalo was the range. Think about it. After this lesson, you will be able to find the domain and range of various functions with restrictions. You will be able to use both interval and inequality notation. All right, so let's do a little review from the last lesson. Identify if the following relations are functions. Then determine the relations are discrete, continuous, or discontinuous. Go ahead. All right, so first of all, these are functions because they are, for every x value, there's only one y value. So we would consider this a function. Now, it's not discrete because it's not a bunch of dots just on the graph, okay? But is it continuous? And is it discontinuous? Well, for the area from x equal to from 0 to 7, it's continuous. For x less than 0 and x greater than 7, it is not continued. So we have a bit of a conundrum there. Okay, well, let's do another one. Now, if we look, we can see right off the bat we have a circle. And at one point here at +3, we have two values going up and down. So this function this is not a function. It's a relation, but it's a circle, therefore it's not a function. Is it continuous? Well, this one would not be continuous because right here we have a hole in the function, in the relation, excuse me. So we have no value there. And since there's no value, it would be considered discontinuous. Right? And this would be a y would be there's a hole at x equal to 1. Let's go through the same process with this graph. Give you a short moment here. So is this a function? And yes, this is a function. Okay, because for every x value, there's only one y value. Is it discrete, continuous, or discontinuous? Well, this is definitely discrete. It's a discrete function. Okay, and why? It's just a group of ordered pairs. Okay, find the domain and the range of the following relations. So we remember we talked about domain is all the x values and the range is all the y values. So here we're going to list our domain and we're going to start at 0 through 7 and they're all the integer values. And that's our domain. Now our range starts at -1, and we go up the integer values up to 6. So -1, 0, 1, 2, 3, 4, 5, and 6. Now, you'll notice there are no values in between. They're just integer values. All right, we have these ordered pairs, and they're all integers. Now, in this instance, we have an infinite number of values that run on the domain because this is a continuous function. So the lowest value here of x is right at this point right here. So here's our lowest value of x, and our highest value of x is right here, right, at 7. And we cover every single value in between. So because of that, we're going to have to use an inequality. So to do that, we're going to say, okay, x is between, right? So how we do this? We would say that 0 is less than or greater than x, which is less than or equal to 7. And because there's so many of those values, we don't bother. We don't listen. We just say it's somewhere between any values between 0, including 0, and 7, and including 7. The same is true for the range. So in this instance, the range, our lowest value is -1, right? We have this value here at -1, and we go all the way up to +6. So we would state that the range is from -1, and y is in between there, and that is less than or equal to 6. You'll notice we use inequalities to express this. All right, so you go ahead and we'll take a moment here and you try it and find the domain and the range of the following relations. And go ahead and you can, on some of these, you can look and see that there are values that are not quite integers there. And that's okay. If you're close, you're close. Okay? Go ahead. All right, so let's look at this domain. So this domain, in this case, the x values, we've got 0. We're not quite to 1. I'm going to say it's 3/4. The next one looks like it's 1 2/3. Next one is 3. Let's say that's 4 1/5, or 4 1/4. We'll go 4 1/4. And then we're at 6, and we're at 7. Okay. On the domain, or excuse me, the range, now we're going to look at the y values. Now, typically we work from low to high, right? So on the low end down here, right at this point here, where I have the number 6 is my low, right? So we're going to say that that is about -1 1/3. Then we go to 0, right? We have 3 of these at 0, so we'll list 0. The next one is this one right here, right? So that's a little bit below 2. So I'm going to say that's, I can say that's 1 and it's eye and the beauty in the eye of the beholder. I'm going to say 1 4/5, right? My next one here is at 2. That's this one right here. So I'm at 2, right on there. And my next one is just below 3, and I'm going to say it's at 2 3/4. Okay. I would never give you a problem like this on a quiz or a test where you have to guess like this. You'll be able to definitely look and see what you're going to have to do. Okay, so. All right, go ahead and now do the domain and the range with this function. I should say relation. Go to work. Okay. So we've got x values are pretty easy here. We're going from 0 to 7. So this is pretty easy to express. And we're going to say that 0 is less than or equal to x, which is less than or equal to 7. Now, let's talk about what we see here. So here's our lowest value right here, and here's our highest value, right? So I might look at that and say, well, that's about -1 1/3, right? So we're going to go with that. So we're going to say the lowest value is -1 1/3, which is less than or equal to y, which is less than or equal to this upper value here, which we said was like 2 3/4 before. So we'll say 2 3/4. So it's a little bit easier to do a continuous function versus a discrete. Now let's talk about what was different about these last two relations and their domains and ranges compared to the previous two. Well, our first two functions came out very nice and even relative to being integer values. The second one, our domain, while our domain on the second couple of these did kind of come out, right? For the most part, you know, most of them were on integer values. Quite a few were, but quite a few were not, right? So we had these two different approaches with this, okay? The final function that we looked at, that one was easier to do because we could just look at what we thought was the high and the low, and we could figure out what that range was. The domain was pretty easy on it. Okay, so when we have a continuous domain and range notation, we can use what's called an inequality or an interval. Okay, so here this is less than or greater than, right? This is less than or equal to if it's included. And greater than or equal to. Now, what we do in interval notation, now what is interval notation? We use this was developed for use with computers. There was confusion with computers, so this was an easy way to do this, okay? if we're using greater than, the low value, and then we go to infinity. Or it's an upper value, or excuse me, it's negative infinity and the upper value. Okay? Or we have a low value and let's say a high value. Okay? When it's a bracket, that means it's included. That's like less than or equal to or greater than or equal to. So this greater than or equal to would be the low to positive infinity. And we always use parentheses with infinity. If it's less than, it's negative infinity to the upper value. And then if we have a bracket between a low value and a high value, it would look like this. So to give you some context here, let's take a look at these. If we have the inequality of x greater than 5, in the interval notation, it would be 5 to infinity. If x is less than 5, we would have negative infinity up to 5. And if we have an interval, we want the values between negative 5 and 5, but we don't want to include negative 5 and 5 because those it's that less than or greater than doesn't include those. We would just put it as negative 5 and 5 in parentheses like an ordered pair. You notice the difference between the inequality x is greater than or equal to 5 and x is greater than 5. We use the bracket at that point. So now we have the bracket 5 to infinity. Infinity always has parentheses. In this one we have negative infinity, again with parentheses, to 5 in bracket. If we want to include our outer values, we put them with the brackets like an ordered pair. Now you can mix and match. So in this case, we have negative 5 is less than x, which is less than or equal to 5. So you can have parentheses negative 5, 5 bracket. Okay? So keep this in mind when you're working on problems and you're trying to figure out domain and range. All right, go ahead and take a moment here and write the domain and range of the following functions in both inequality and interval notation. Go to work. Okay, so let's talk about the domain. So the domain is always the x values, right? So over here we start at this point right here, right, at negative 3, and we are going to positive 3. So this function has values in the domain of between, so it's be negative 3 is less than or equal to x, which is less than or equal to positive 3. Now, we would write this as, in interval notation, as from negative 3 to positive 3, just like this. Now let's talk about our range. So our range runs from a high value of 6, and the low value is down here at negative 3. So we would go ahead and state that as as an inequality. We would say this is from negative 3 is less than or equal to y, which is less than or equal to 6. And then our interval notation would be negative 3 to 6, and both of these are in brackets. right, take a look at this one and really think about it. Pay close attention in the graph and write the domains and ranges of those functions, of the function. All right, so our function, we start here. Let's talk about our x values here. So our x value starts at -6, and it continues all the way to 10 here. But here's one of the things we really need to pay attention to. This arrow says this is going to continue on. So this domain is going to go to infinity. So I would state this in inequality form as x is greater than or equal to -6. Since this has a dot here, -6 is included. So we're going to throw this with the bracket, and it's going to be -6 to infinity. Now our y values start at +4, and they travel down. Well, that's pretty pretty crooked there. Let's see what we can do, but there we go. Now, our y values, as we stated, start at +4 and go down. So, we're going to state this, that y is less than or equal to +4. And we would do this in interval notation as, well, we're going to -infinity, and we stop at 4. So we're going from -infinity up to 4. Go ahead and try this one. Okay, so again, we're back here. We're starting at this point here, right? We're starting at +3, and this goes to the left, right? It's going to -infinity. Keeping in mind, we have this arrow here, and that means it's going to continue going left and down. So how do we say this in math? Well, we would say in this case that x, it's got a circle here, a little hole there, so we're not including 3. It gets real close to 3, but it doesn't touch 3. So x less than 3. We would state our interval notation as -infinity to 3 parentheses. Now our range values, they get up here up to 3, and then they go south, right? Goes down. So the high is here at 3. So we would say that with this function, that the y value, oops, I'm doing the wrong thing there. I'm going to do my inequality. So y would be less than or equal to 3 because it touches 3. There's no hole there. So we can assume it touches 3. And then we would state this as -infinity to 3, and then with the bracket